Hello, everybody. So I'm going to do this example that's located inside your notes because I want to make sure that you see how to construct the relative frequency distribution. So the test scores on a 100-point test were recorded for 20 students, and what we want to do here is construct a relative frequency distribution for the data using 6 classes. And then we have the data below, so it ranges anywhere from like let's see, the smallest number I think would be 53 all the way up to like 94 or something like that, and everything in between. So if you go back into your notes, I just want you to remember that there is a method on how we do this. And step number one is always to choose the number of classes. Now, I'm always going to tell you how many classes I want. That way, we have consistency throughout the entire class. All right. But if you were doing your own study or something like that, you could use 5, 6, 7, 8, even 20 classes. It all depends on how many data values you have, and there is no right or wrong way. It's kind of like if you do a relative frequency distribution with 10 classes and then you do it with 15, maybe the 15 looks better than the 10, and that's really what you're looking for. Okay. Now, step number 2 is we always want to find our class width. All right. So if you just remember from the notes, the class width is the max value minus our min value, and this is all divided by the number of classes. Okay. And we always round this number up. All right. So we always round up. Okay. So for us, let's go ahead. Let's look at what we have here. So it looks like the maximum value is going to be, I'll just put CW equals, maximum value is 92. Oh, sorry, 97. My bad. Minus the minimum value is 52. And we're going to divide this by 6. So that's going to give us 7.5, which we're going to round up to 8. So 8 is going to be our class width. Now, step number 3 is to go ahead and start to build your lower class boundaries. All right. So I'm going to write just create class boundaries. All right. And here's how we do this. All right. So I'm going to create like a little table here. On the left hand side, I'm going to write class boundaries. On the right hand side, I'm going to write relative frequency. Okay. And we know we want 6 of them. All right. So just give me a second here. There's 1, 2, 3, 4. Zoom out a little bit. 1, 2, 3, 4, 5, and 6. All right. So kind of square this away a little bit. Make this look pretty. There we go. It's not exactly the best looking thing that I've ever made, but it'll work. Now, we use a rule called the method of left inclusion. All right, so I'm going to write this over here on the right hand side. The method of left inclusion. And all that really means is that our lower class limits, all right, which are going to be the left number, is going to be the number that we include, hence the name method of left inclusion. And then the right number, in other words, the upper class boundary, we're going to make it just less than that value. So let me explain what I mean here. All right. So when we look at our data set here, okay, we know that the minimum value is 52. That is going to start our first lower class boundary. So this is going to be 52. All right. And we're going to take all the numbers from 52 to less than 60. Okay? And that's how we kind of build this up. But the best thing to do is to create all your lower class boundaries first. So what I mean by that is since we have 52, we're going to take 52 and we're going to add 8 to it. So 52 plus 8 is going to equal 60. That is going to be our next lower class boundary for class number 2. All right. Then we're going to add 8 again to give me 68. There is our third class. We add 8 again for 76. We add 8 again for 84. And then we add 8 again to get us 92. Now, if you notice in the first boundary, and I'm going to highlight so you know exactly where I'm looking here, we have in the first class 52 to less than 60, and then the next class starts at 60. So that's how we can kind of get around any numbers that fall in between 60, like 60.1 or 60.4 or 60.7, because we use this method of left inclusion. All right. So we're going to continue with this. So 62 less than 68, 68 to less than 76, 76 to less than 84, 84 to less than 92, and finally 92 all the way up to 100. Now, for this very last class, I'm not going to use the less than symbol because I want to make sure that I capture all of my values, and just in case one of the values just happens to be 100, I know I have it. So now we have to calculate the relative frequency, okay? So I'm just going to erase some stuff here on the right-hand side. So we're going to erase that and those things. So remember, relative frequency, just abbreviate here, is equal to the frequency count divided by the total number of values. Okay? So, for example, for the class boundaries between 52 and 60, there are going to be 3 numbers. Okay? So, that is going to be my frequency count. And then to calculate my relative frequency, I'm going to take 3 and divide it by 20 because the problem said there were 20 test scores. So 3 divided by 20 equals 0.15. All right. And that's how we get the relative frequency. So I'll do the next one. So between 60 to less than 68, we're going to have 5 values. So to calculate the relative frequency for that, it's going to be 5 divided by 20, which is going to be 0.25. And we do this for all of the other classes that we have. So I'm just going to kind of give you the frequencies. I think you kind of have it from here. So between 68 and 76, there's going to be 2. So that's going to give us 0.1. 76 to 84 is 2 again. So that's going to give us 0.1 again. Finally, the last 2, we have 5 for 84 to less than 92. This will be 5 over 20, which we know is 0.25. And finally, between 92 all the way up to 100, there are 3 values, which gives us 0.15. And the hardest part about this, all right, to be completely honest, is to go back to your data and just count the number of values that fall within each class. All right. So that's going to be the hardest part. Traditionally, I like to just like scratch numbers out myself. All right. I just scratch them out, but you could do whatever you want. You do whatever you want. I'm not here to reinvent the wheel. All right. What I'm here to do is teach you how to construct a relative frequency distribution. So now that we have our relative frequency distribution here, how do we actually create like a model or a table, all right, or a graph, all right? And it's going to be very simple, all right? So the first thing we have to do is we're going to construct an XY axis, and along the X axis, it's always going to be the number. You know what? Let's make this better. I'm going to call it just class boundaries. I think that's better. Okay? And the y-axis will always be the relative frequency. Okay, now, Do you remember that method of left inclusion? That's going to really come into play here because across the x axis, all right, where we have our class boundaries, all right, we're going to use our lower class boundaries to construct the, I guess, if you want to call them like little tick marks along the x axis. I'm sure there's a technical term that I'm just forgetting right now. But who cares? So I got 52. Oh, can't write today. 52, 60, 68, 76, 84, 92, and 100. Now, the y-axis is going to be the relative frequencies. So I kind of just scan my relative frequencies, and I'm going to highlight them here for us. So here they are right here. And I noticed that the smallest relative frequency is 0.01. All right, and the largest is going to be 0.25. So therefore, when I go ahead and make my relative frequency axes, I'm not going to get too crazy with this. I'll just make this 0.1, make this one 0.2, and then I can go ahead and build all my bars based off this. Okay, so from 52 to less than 60, our relative frequency was 0.15. So I'm going to put it like right there. And I'll just shade it in a little bit here, give it some pizzazz. Now between 60 and 68, all right, we have a relative frequency of 0.25. So we're going to make it up here. And this is all you do. It's very, very straightforward. Okay. So I'm going to finish this out now from 68 to 76.1. And from 76 to 84, we got a 0.1 as well. All right. From 84 to less than 92, it's going to be 0.25. So that's going to be all the way up here. And finally, 92 to 100, 0.15. So we got to put it like back up here. All right. And what this really does for us at the end of the day, all right? And I love math. I love stats. One of my favorite courses to teach. However, if I scroll up and just look at this, this is just a wall of numbers. That's all it is. Okay. It gives me no really idea of like what the scores look like over this test, whatever it was. Maybe it was a quiz or something like that, right? But as soon as I start to organize my data a little bit, as soon as I start to say, okay, well, I can create a table, and that table gives me a really good inclination of the scores. So, like for example, I know a lot of people got between 60 and less than 68, and 84 to less than 92. Like I know that, right? So that helps me to understand the data a little bit more. But let's be honest, everybody loves a picture. And that picture really demonstrates, it really shows me, oh, this test was bimodal because I have two very large peaks, one between 60 and less than 68, and 84 to less than 92. So it's a bimodal, all right? And that's really what we want to do with data. Anytime you collect numbers, anytime you're collecting data, the best thing to do is try to organize it and make a picture based off what you've collected. Because at the end of the day, you're the statistician and you're presenting this to people who might have never taken a stats course before in their life. So you got to make sure that you make it easily accessible and readable for those. And I hope this helped, and I will see you in the next example.